Cool. How is everybody?
Oh, feeling pretty wiped after the weekend.
Yeah. Anybody go trick or treating?
Yeah, I took my daughter last night.
Cool.
This is kind of the first year that she actually showed any kind of excitement towards it. She's only 2.5 right now.
Oh wow.
Actually, didn't care, obviously.
That's cool. All right. Well, my plan is to talk about PA3 and make some general comments on it, and also talk about just go through some sample code for an executable, and then talk about some more Unix things, symbolic links, the tar command, stuff like that, and then move back to some ODPs tomorrow and start talking about string processing and handling in C, getting more into arrays of characters and all of that. Any questions before we start with all that? All right, well, send me an attendance note, please. And I'm available every day, 8:30 to 9:30 for office hours. And if you have like a work conflict or a class conflict during that time, send me an email and we'll figure out a time to talk. All right. Also, I posted a survey on Thursday asking about 222 and 215 for winter, and across the two sections, I've only gotten about 2/3 of the students to respond, and that's an issue because that's potentially the difference between 20 people enrolling in a class and 30 people enrolling, and if we think there's going to be 20 people, we can do that in person with a normal sized room. If we think there's going to be 30, we need to find a bigger room. So if I don't get, responses that indicate 30 people want to take 222 in person, for example, we're probably going to go with a smaller room. And then if it fills up, people will be forced into the online section. So if you care about 222 in winter, definitely respond to that survey today so that we can make sure we know what the numbers will look like. I also asked about 215 just to get a read on how many people are planning to take 215, and a number of people said they needed more information to make that decision. So you should have a plan of study from me or from Izad that lists CSE215 for either fall or winter of this year, unless you've previously taken it, or you're not planning to transfer to a university in computer science. If you are planning to transfer and you're planning to transfer, this coming fall, you definitely need CSE215 either this quarter or in winter. It's not offered in spring, and if you don't take it this quarter or next, then you would have to take it somewhere else or wait another year before you can take junior level classes. So send me an email if you need to talk about that, and we can meet and go over your plan of study. All right, so programming assignment 3, I graded them. I ran a series of tests. I used the grading rubric from the assignment, posted grades and posted feedback if there were any deductions. And as I mentioned in the announcement, if you want to know about specific cases, if you think that I took off points for something that you think you tested and worked fine, right? We can meet in Zoom, and I can run through some test cases, and we can go from there. Or if you didn't get the assignment done, or you got it partially done but it wouldn't compile or it wouldn't run or something like that, let's definitely talk, and let's figure out where you are with that assignment and what you need to do to be able to finish it, just for the sake of, you know, being able to build on top of that for future assignments, and, you know, for preparation for the final. So you know, main deductions, which were from the grading rubric. So everybody named the program main, so no deductions there. That's good. Had to work with no arguments, 0 to 100, one argument, 0 to whatever you specify, and 2 arguments where you specify both the low and high. So it needed to work in all those cases. Needed to handle the command line arguments if there were errors. So if you don't specify an integer for one or both of those, it should throw an error and not continue. Needed to print a greeting in the beginning, tell the user what the range of numbers is they're trying to pick a number from. It should wait for the user to think of a number and hit enter to indicate that they've thought of a number. Should predict the number of guesses, print the number of the guess after each guess, and so on. So these were all things that I ran different tests for to check. If your code did not compile, I generally, you know, went into it and tried to see if I could easily fix whatever the error was. And sometimes, you know, there's one semicolon missing somewhere, or someone adds a comment at the last minute. They put their name in the top, but they forget to put 2 slashes in the front, so it looks like a syntax error. So if I could easily fix the issue, I took off points with a notice of does not compile, but then went ahead and graded the rest of the program. But you always want to make sure that your code compiles and runs, and we're going to talk about how you can do that with an assignment, so that in the future, you know, you can be absolutely sure what my experience is going to be when I try to grade your work. Responding high, low, or correct, again, had to be exactly H enter, L enter, or C enter, and anything else should throw an error. And so I did test that, and we talked a lot about using string compare to pick up, you know, extra spaces after an H, and so on and so forth. Cheat detection should happen every time. Splitting into the required pieces and then having a make file. So splitting into the required pieces, there were a few cases where people use different function prototypes. For example, passing high and low to the intro function. I did not take off for those in this case. But it's a really big deal if you're asked to create a function with a certain prototype. You've got to use that prototype. If you decide to, you know, pass a pair of integers so that you can do some extra feature, you will break the project that you're working on. And people will try to put all the pieces together, and your piece won't fit in because it has a different prototype. So make sure you understand, you know, what the prototype is and why it's a different thing if you have different arguments, for example. And then the make file, as the assignment said, should, you know, selectively compile programs. Everybody did that. I didn't see any, you know, cases of just compiling everything together. But also it needs to have a clean option, and it should selectively remove the pieces that are built by the make file. So let me show you some sample code.
I used the make file in the style that you had on your short video and adapted it to the prototypes that I have in the program. But when I was talking with a friend about make files, he was showing me that he uses kind of a skeleton for his.
Mm-hmm.
That you know has like the target and the object files kind of like laid out in bash above.
Okay.
And a list, and then but like your method obviously seems kind of like recursive for being able to compile specific functions that are changed.
Right.
I'm trying to search for my question. I have.
Okay.
I can't quite think of how to phrase it. Don't think on that for a minute.
Let me take a look at your make file. Hold on 1 second. I saw a few that were interesting.
Mine should be straightforward, like how you.
Yeah, yours is totally what I was showing in class. So I mean, you can make a general make file that, for example, finds everything, named .c and compiles it and links it together and so on and so forth, and uses wildcards maybe so that you can drop it into any directory. But that's a kind of dangerous thing to do. You really want your make file to be a very specific recipe. So if you're going to make soup and it's your kitchen, you can say grab everything from this shelf and put it in a big pot and cook it, right? But if somebody in a different kitchen tries to do that and they've got weird ingredients on their shelf, if they follow that recipe, they're going to get something weird. So that's why you want to make sure you're selective about which files. Let's see what you just did here.
Specifically I kind of picked that apart and understood what was going on with it, and then I was looking at like object files and how we had different object files linked to different use cases in the version that you specified. Something like this where you're laying them out at the top, I didn't see it as being adaptive. I don't know if it would be smart enough to know which ones need to be updated, or maybe that's.
So if you made a symbol like object files and listed all of the .o files that you want, you could put that at the top, and that would be nice, because then if you wanted to add a new file or remove one, right, you could just do it in that one spot. And I don't know if what you typed in chat exactly would do that, but I believe you could make a make file that was driven by setting up a symbol with a space separated list of targets.
Okay, yeah, I was worried this was kind of one use case when I was looking at.
Yeah, make files is one of those things where make files can be thousands of lines long and do all kinds of things, and especially when you're targeting multiple platforms, and you want to be able to have somebody 5 years from now download this on their Raspberry Pi 7, which is running some other operating system, and know that they can just say make and get an executable program. These can start getting really sophisticated. And usually before you do a make file, you usually run something called config. And config does things like, what's the version of the C compiler on this system? What's the exact library for such and such that's going to get linked in? And config will actually help tailor the make file for the particular system. So first you say config, and then you say make all, and it does the right thing. Except for me. I have horrible luck with make files like that. Anytime I try to download something and make it, I end up spending the rest of the day going in and editing code and all this kind of stuff. But in theory it works great. I think the space of possible platforms and configurations has just grown so far in the past few decades, where there's so many different versions of Linux and so many hardware platforms and so on. So yeah, if your make file worked, right, and if it had a clean option and it wasn't just, you know, removing everything for the clean and so on. You got credit for the make file. If the make file didn't work, right, then you got a deduction for that, and then I went ahead and tried to compile by hand. And I think in all cases on this I was able to do that. But if you don't have a working make file, keep in mind that I need to have some way to build your executable. And so if you have, you know, 5 different versions of your main program, it's probably good to move 4 of those, you know, into a different directory, so that you have just the pieces of your program that you want me to try to compile and link. So that can help sometimes. All right, let's see. So sample code. So here's my sample PA3. This is the code that turned into the test target that you could run on the server. So the README is just kind of, you know, high-low game, course number, date, and my name. Synopsis of the program, right, what it does. Description of the algorithm. It's using this thing we call divide and conquer, splits the range in half at each guess. Other features, also predicts the maximum required number of guesses. If the range flips at some point, we call cheating. 3 ways to run the game: main, main high, or main low high, and what each of those different ways does. And in all cases, low has to be non-negative, high has to be bigger than low, and they have to be integers. Anything else throws an error message. And if you want to build it, you can say make clean and then make, and it creates an executable called main. And so the idea of this README is if I were to put this repository on GitLab and make it publicly available, and someone's like, oh, a high-low game, I've never played that, let me download it and play it, they would download it and they would look for a README file. And typically when you look on GitLab at the front page of a repository, if there's a readme.md file, that will be displayed right there on the front page. And so they would see all of this information, and they can see, you know, who wrote this, when they wrote it, what it is, how to use it, and how to build it. Right? So that's some of the stuff you might put in a README, right? Information that would help somebody who was just coming into this be able to work with it. So I've got, you know, a bunch of .c files, I've got a .h file, and I've got a make file. And so the make file looks, you know, more or less like what we've been talking about in class. I did, in this one, I used some symbols. So instead of hardwiring GCC here, I used a symbol CC, which means GCC. But if I wanted to compile this with a different version of C, right, I could just change this command. And then I have these C flags. And if I said C flags equals -G, then it puts a -G after each of my GCC commands. Lets me build with debugging. If I said C flags to blank, then all of this just translates to GCC, GCC, GCC. And that looks like the file we were working with last week.
So if you make a variable equal to nothing, it'll just ignore it?
Yeah, it's just an empty string with 0 length, so this gets replaced with nothing.
Oh, that's good.
Yeah, it's a little quirky, but that works. Yeah, it's makes are kind of like bashy, but you know, this is a little weird. You got to do $ parentheses in the name of the variable. So if I just say make, it's going to try to build the first target, which is main. I could also say make main, and that would build this. If I had multiple targets in here, typically your first target would be something like all, and it would list all of the different files that you could make. And then if you say make space all, builds all of those. So we can just say make, and it should build the first thing, which is main. And for that to happen, I need these 4 object files. And I don't list any .c files here. I don't list my main.h here because I don't care about my source files at this point. I just want to know, are these files up to date? If they are, I'm ready to link them. And here's my link command, including the lm switch to pick up log. If I change intro.c This part of the make file will say, hey, intro.o needs to be rebuilt because it's older than intro.c. And so before I use intro.o here, the make utility will say, hey, let's rebuild this. It'll recompile intro.c, and then it'll go ahead and use that new intro. If main.h changes, I only use main.h inside main.c. So if main.h changes, when I get to main.o, the make utility will look here and say, this depends on main.c and main.h. This file is newer than that. Let's recompile. It'll rebuild main.c into main.o, and that's where main.h gets used. And then when this is up to date, all of these will get linked together. That makes my executable main. So almost every make file I looked at this weekend was perfect, which is fantastic. That has never happened. It's never come close to that. And you know, I know a lot of people sort of use the template that was posted on the Linux server and work from there. That's the thing to do, right? And you know, keep yourself a make file and go back to it and refer to it when you want to start a new project. That's good code reuse. So this was great. The only thing, some people were missing the clean option, which you can use to sort of reset the state of everything. So if I just say make, it'll tell me main is up to date because everything's already been compiled. So I can say make clean, and that gets rid of all the stuff that's built by the make utility. So now I have my source files .c, my source file h, my make file, and my readme, and that's it. So now if I say make, it recompiles everything, relinks it into my executable, and there's my main program. And then main is the program that you were using from /temp. All right, so source code. So main.h was just a few function prototypes. So I only broke this into separate functions that were described in the assignment. You could break it into more pieces, but I just kind of stuck with the letter of the law. So main program, sample code for PA3 fall 2020. This should be 2021 now. There we go. So include main.h, right? That's your functions. Don't include, you know, intro.c. Don't include getAnswer.c. We don't want those to be part of main.c. Anytime that you say include, it says take the contents of this and put it right here in my file. Well, we don't need the source code for intro.c because we're going to compile intro.c separately, get an intro.o, and link that. And I have one other function in here, error, which just prints an error message. So main program, we definitely need argc, argv, because we can pass arguments. And so all of this is trying to set up the low-high range for the game. So I have a low bound and a high bound. They default to 0 and 100. And then if you say main space something, argc will be 2. So in that case, do our usual scanf trick on argv bracket 1. And if it doesn't return exactly 1, that's an error. So this will print an error message and I do a return. If this fires though, if argc is 2 and the scanf works correctly, I'm saving that integer version of your argument into high. And I don't have to say high equals something after this. High will be loaded. So if argc is 2, low will still be 0 because I haven't changed it, but high will be whatever that argument was. If argc is 3, I'll take that first argument, try to parse that into low, second one gets parsed into high. If either of those fail, we'll throw an error and exit. Otherwise, you know, low and high will be set. And then down here, I check to see if argc is too big. If you have more than 2 arguments, I throw an error message and I exit. All of that means when I get down to this green line, low and high are set. They could be set because they were taken as defaults, or because high was specified, or because both low and high were specified. But whatever possible use case is at play here, When I get to this big green line right here, low and high are set. They're the range I want to play in. And now I can forget about argc, argv, parsing integers, scanf, extra, all of that stuff, right? In my mind, I've got argc and argv low and high set. So we have a range. Is it legal? One final check to make sure that low is non-negative and high is bigger than low. And if that's not the case, there's an error, and we exit. Now when I get here, low and high are set and they're legal, we're ready to play the game. So now I print out a hi message, right? Just say hello. And then I say, think of a number between this and this, hit enter when you're ready. And then I do an fgets just to wait for the person to hit enter. Then we make our prediction. I will guess your number in at most %d guesses, and I use the predict function to get that. And now we're ready to do our main game loop. So guess is going to be the number that the computer is guessing. Guess num is the number of the guess starting with 1. Done is a flag that we're going to set to 1 when we're done playing the game. And then here's our main loop. So while we're not done, make a guess right in the middle of high and low. Print it out along with the guess number. Increment the guess number after I print it. And then ask the user, is my guess high, low, or correct? So the getAnswer function packages all of that behavior, and it returns a character. So I take a character variable answer, set it equal to getAnswer. Now answer is either HL or C, guaranteed. If the person typed in anything else, they'll still be in getAnswer being asked to try again. So when I return from getAnswer, this is either HL or C. So if it's H, adjust the high guess. If it's L, adjust the low guess. Otherwise, it must be C, and I'll just set my done flag to 1, which will cause me to exit this while loop. All right, at this point, I also check for cheating. If low is bigger than high, something went wrong, and I'll set the done flag to 1, which will kick me out of the loop. And then I just go back up to the top of the loop. And if we're not exiting, we take the new high and low, we make a new guess, and we continue. And then when we come out of the loop, we just say thanks for playing and we exit. And the error message just shows you a usage message. Use either main high value, or main low high. So intro is just a bunch of prints. That's just, hello. Predict is just the log business that we went over in the assignment. So take the range between high and low, add 1. Take the log base 2, you can use log 2, or you can divide by the log of 2, and then add 1 to that, return it as an integer. That's the maximum number of guesses you need. And the getAnswer is a little more involved, but not too bad. Read an HLC from the user who's already been prompted, and return that single character. So we printed the prompt outside in main before we called getAnswer, but inside here, if the user types in anything other than HL or C, we will reprompt them and input again. So I'll do my prompt again and do my gets. And we continue until they type in what we consider to be valid. So this is a forever loop, right? But basically do your fgets. So we talked about doing string compare, in this case buffer, to like h\n or l\n. Just for kicks, right? In this one, what I decided to do was remove the last character of that input. So if they type, hello, instead of having buffer be hello\n, I remove that \n and buffer is just hello. And we'll play with this tomorrow. We'll start taking apart strings and seeing how things like this let us remove the last character and so on. But in this case, so I could just compare my buffer to an H, an L, or a C as a string. So if it's an H, return the character H. If it's L or C, return the character L or C. Otherwise, print a message and go back up to the top of the loop. And remember, as soon as you return, you exit the function. And so if I exit right here, right, I'm never going to do this, I'm never going to do that. And the whole idea of this is when I say something like answer equals get answer, right? All of that behavior is hidden inside this get answer function. And in my main program, all I care is find out if the guess was high, low, or correct, and save that as a single character in this variable called answer. And then I can write some logic based on whether answer is H or L. But that get answer, you know, involves some looping and some prompting and some parsing and some string massaging and so on. All of that goes into a function. So my main program is simpler, and I could debug this function by itself. I can just make a main program that just calls get answer, returns the result of that, and I can debug this, you know, in isolation. So that's part of this goal of breaking things into functions like this. It's to streamline the development and make it easier to debug. And make it easier to work with. Alright, so questions about any of that? Alright, so how do you check your submission? So, let's see. Oh, I cannot type. So, I don't have a whole lot of stuff in here. Alright, so I'm gonna pretend that I'm doing this class. Typing too fast here. Interesting. All right. So presumably I didn't just do this, you know, at the last minute before I was ready to submit my assignment. Presumably I did this, you know, throughout the week. But I've got my code, you know, pushed over to GitLab, and I go in my PA3 area, and I forgot to put my name on it, right? So I put my full name in there, and I want to go ahead and add this. And you know, maybe I messed up my file in the process. And I don't notice. So I submit my project and I leave for the weekend, right? So before you close your laptop and say I'm done with PA3, right? You always want to double check your submission. And you can do this by replicating exactly what I'm going to do when I grade your assignment. And so your kind of acid test is pull your assignment back down from GitLab and try to rebuild it. And after you've rebuilt it, run your tests that you've been using to test your program and make sure that it still does, what it's supposed to do. So how do you do this? Make yourself a totally bogus directory. I'm just going to call it check this. There's nothing in here. There's no Git repository in here. It's a totally empty directory. Okay. Use a git clone. Git clone, git at gitlab.com, your user ID, /CSE224.git. And this should create an exact copy of your CSE224 repository, but it's not just copying it from your hard drive, it's pulling it from GitLab. Okay? And this is what I do to grade your assignment. I do a clone on your repo using your Git ID that you sent me back in the beginning of the course. And now there's a new directory under here called CSE224. Go into your PA3 area, there's your project, right? Do a make clean to get rid of all the stuff that's already been built. Do a make, and bingo, you can see, hey, wait a minute, what happened? Something's wrong. If I say make on your project and I get this, it's probably a really low grade, right? I'm probably not going to be able to debug all of this and figure out, what went wrong in your code. What went wrong was I'm missing one character in the very beginning of my comments. But, this is the result. And certainly if you do this, like at a university, you got a 0. And your code might be, perfect except for this one thing. Alright, so what do you do about this? Go back into your real CSE224 directory and try making your project. And yeah, there's a problem in there. Okay, so do your usual debugging. Maybe you remember the last thing you changed was main.c. Oh yeah, I deleted my slash in the beginning there. So put that back in, and now try to make everything works great. Alright. Alright, I want to make absolutely sure that this works correctly. Let's go back in to check this. I'm going to rename CSE224 to be my old CSE224. And then I'm just going to redo my git clone. Go into CSE224, go into PA3, make clean, make, there we go. Let's try our main program. And it seems to work. Right? So you can always do this, and you really need to do this, right? It's so easy for something to go wrong, especially at the last minute, especially if you've made, some panic last change, like you talk to a friend and they're like, well, did you remember to do such and such? And you're like, oh, I forgot to do that. That was worth 40 points. So you go and you make a quick change and you resubmit, right? Always, after you're done with that, take a breath, pull your repo back down into a totally new area, do a clean, do a make, run your test cases, make sure it still works. Alright, let's see, cheat detection, somebody asked in chat. So a couple of different things I tried for cheat detection. The first is, forget your number, so let's go low, high. First I tried, for like 60, so this is high, this is low, this is low, this is correct. Okay, that's good. Then I tried forgetting my number, so I'll say this is low, and then I'll just keep saying these are too high. So 50 is too low. If I tell it 51 is high, that should say something's wrong. And then try telling it everything is low, and it should guess 100, but if 100 is low, that's cheating. And then try to see if you say everything is high, it should guess 0, but if I tell it 0 is high, that should throw a cheat also. And so those were some test cases I used. All right, so questions. Questions on any of that or anything related to that? All right, let's change gears. Oh, let's see. Other thing I wanted to mention in there, don't use go-tos in your code, right? Just avoid those completely. There were a few cases where somebody had one and their code was almost working, and so I said, okay, that's fine this time, but definitely going forward and for any other course you take other than assembly language, don't ever put a go-to in your code. A lot of teachers will just give you a 0 right away. So watch out for that.
Is that a valid command too? Go-to?
Yeah, it is. Yeah, you can put a label with a colon and then say go to label, and it'll jump up to that that part of your program. But you know, in the 80s, people started to worry a lot about the cost of maintaining code, and realized that with go-tos, it's possible to write code that's extremely confusing and hard to follow. And decided, you know, we should not be doing that. And the historic problem with it really was, you know, you write code, you do some intro, you do some process, you do some finish, and your code kind of flows like that, and that's pretty easy to work with. And when the person who wrote that code retires and somebody else comes in to take over that code, they can follow this. But now you need to add some extra feature in your process. And so a typical way to do this was, you know, do a few things in your process and then jump down here somewhere else, do a few other things, and then jump back and continue. And then do your finish. Well, that's not too bad until, you know, this is supposed to start doing something different, so you jump somewhere else and do some stuff and jump back. And then maybe somewhere else in your code you want to do something similar, and you don't want to rewrite the code, so you set a flag and you jump over to here, but this time because of the code it'll like jump back here, and so you get, you know, what's called spaghetti code, and it becomes increasingly difficult to follow what the program is doing and to be able to make changes to it. And so people decided, you know, that was the fault of using go-tos kind of recklessly. So your program still executes go-tos internally when you do a loop. When you do a conditional, those are go-tos, but they're go-tos that are being created by the compiler in response to these more structured statements, which are loops and conditionals. And so it's pretty universally considered poor form if you write code with go-tos in it in something like C, and it will definitely get you negative points in a job interview, for example. Unless, you know, it's a really sneaky interview and they say, you know, write a C program to do this using only go-tos, don't use any loop statements, and then you'd want to know how to do it. So you have to refer to your assembly language background then. I don't know if that's ever been asked in an interview. I would think.
Yeah, you'd think if you're trying to avoid it, they wouldn't ask you to show that you can do it.
Well, I don't know. I think I would probably ask. Because to be able to do that, right, you'd have to be able to sort of figure out on the fly something that you might not have learned in school or studied in a interview training session or something like that. But that's a good question. You should like post that on Stack Overflow and say, hey, I heard that a friend had a friend who got asked to use a go-to in an interview. What do you think? And then make a big bowl of popcorn and watch what happens.
I'll just post the Michael Jackson meme underneath that if they beat popcorn.
Yeah. All right, so let's talk about inodes. So I think we started to talk about this a little bit last week. This idea that if you do an ls-l on a directory, you get, you know, a list of files and possibly directories. And this first character here is usually just a dash. If there's a directory, this will be a D. And we looked at, you know, I/O devices, and this was a B or a C for I/O devices, and so on. If we do an ls-il, we also get this magic number in the beginning, which we call an inode number. It's the numeric reference to this file. We call this file getanswer.c, but the computer calls it file 5114251. And each file has its own inode number, and it's how it gets to information about the file. So so we can create what's called a symbolic link. And a symbolic link is a way to have two files where one file refers to another. So for example, I could say, let's make a symbolic link called high-low. And I want high-low to be a reference to this file that already exists called main. So I'm going to say ln, that's the command for link, -s says let's make a symbolic link. We'll see what that means shortly. Here's the file I'm linking to, here's the new file. And now when I do an ls-l, I did SL. When I do an ls-l, high-low is listed with this little symbol over here which says, hey, high-low is a reference to main. And this first character is an L saying this is a link. And this is strictly just a symbolic thing, right? Whatever main is, that's what high-low refers to. So if I say high-low, it goes ahead and runs my main program. If I change main so that it's not executable, and I run high-low, it'll say permission denied. If I change main to be executable again, and I try to run high-low, it'll run main. So it's a symbolic reference. And if I remove main, that reference is still there. It still says, hey, when you say high-low, we're talking about the file main. But, you know, if I try to run it, it'll say command not found because there is no main in this directory. And if I say make to recreate my main, high-low refers to something that exists now, so it goes ahead and runs it. So that's a symbolic link. The other version is a hard link, and we'll play with those tomorrow. It's hard links basically create two references to the same stuff on disk. So we'll create two files and they'll have exactly the same inode number, which means they'll be the same file in effect. And we don't encounter hard links very often, but we'll talk about them tomorrow. It'll take about a minute to talk about, and then I want to talk about some other utilities in Unix. I want to talk about the tar command for creating archives. I want to talk about gzip, which is like zip, and I want to mention the find command. And then we're going to go back and we're going to start talking more about string handling in C, so dealing with arrays of characters. So send me an attendance note on the way out. Take the survey in Canvas today if you can. It's at the very top of the Canvas page. It'll take you about a minute to do, and that'll help a lot for winter quarter. And then have a good one, and I will see you next time.